third presenter is Dr. Jordi Casas, and he will be talking about anonymizing graphs, measuring quality for clustering.
Good morning to everyone. So, this presentation will be divided into 5 parts. First of all, we'll talk about the motivation. Then we define the information loss measures. Next, we'll explain our experimental framework, and then we go to the results. And finally, we'll talk about the conclusions. Here we can see the scenario in which the owner of the data wants to publicly release his data to researchers and third parties. But he must preserve the user's privacy. And usually most of the anonymization methods are based on adding, removing, or swapping edges in the network. So in this work, we have focused on how to analyze data utility on anonymous data. So we observe that there are several graph mining tasks and too many methods to compute this task. So it's so hard to analyze all of them. So we ask, can we use some generic graph metrics to predict real graph mining tasks? And there are several generic information loss measures which evaluates some graph properties. And we compute the error on this measure using this scheme in which we compare the value of the metric on the original and on the anonymous or perturbed network, and we get simply a score which is the error on this measure. And we analyze several network metrics, average distance, diameter, harmonic mean of the shorted distance, subgraph centrality, transitivity, edge intersection, clustering coefficient, and modularity. All these metrics are evaluated using equation 1, which simply subtracts the score of these metrics, which evaluates the whole network. We also use 2 spectral metrics, which are the largest eigenvalue of the adjacency matrix and the second smallest eigenvalue of the Laplacian matrix, and 2 vertex centrality measures, and we use equation 2 to compute the error on these measures. And then we have focused our graph mining tasks into clustering or community detection task, which is one of the most active graph mining processes recently. So here we start from the original network and we apply some anonymization or perturbation process to introduce noise in the data. And then we apply the same clustering method both to the original and to the perturbed data. And then we use the precision index to compute the matching between the original and the anonymous clusters. So equation 3 is the precision index, how we compute the matching between the clusters. And we use 6 different clustering and community detection algorithms, which are the Markov cluster algorithm, the Girvan and Newman algorithm, the fast greedy modularity, wall trap, infomap, and multilevel in our experiments. And more or less this is the framework of our experimental setup. We start from the original network and we apply a perturbation which ranges from 1% to 25% using different edge modification techniques like adding, removing, or swapping edges. And then for each one of these perturbed data sets, we analyze all these generic information loss measures we have seen previously and all the clustering specific information loss measures. And then we try to correlate or to compare these values in order to establish a correlation between them. So first of all, we ask, do the generic information loss measures behave in similar way independently of the data set? And as we can see here, some of them, almost all of them, achieves a strong or very strong correlation with values higher than 0.9. But the spectral measures and the diameter shows a weak or very weak correlation with themselves, which means that they behave in different way according to the data or to the properties of the data. Next, we apply the same experiment to the clustering specific information loss measures. And as we have seen, using 3 of our 6 clustering methods, the results are still a strong correlation, to moderate correlation, so using Waltrap and Infomap, and Markov clustering algorithms achieves a weak correlation. So in this table we can see the correlation between all these generic information loss measures and the clustering specific ones. And as we can see, some of them achieves a strong correlation, which means that these measures are able to predict the real data utility in clustering processes. These measures are the most important one, the closeness centrality and clustering coefficient, but also average distance between the centrality, edge intersection, and transitivity are able to predict the real behavior of the data on clustering processes. So next, we try to analyze if more than one generic information loss measures can help us to improve the correlation. So we use a multivariate regression analysis to compute the correlation between an aggregate set of generic information loss measures. And as we can see here, the values are slightly higher, but we are adding some computational cost, which can be good for some cases, but not for all of them. So we can add more than one measure, and we will get slightly higher values. And finally, we are interested in proof that our experiments are independently of the data where they are applied. So we applied the experiments in different data sets and try to establish the correlation averaged values and the deviation. And as we can see, the values are more or less the same for all the data sets, which means that the results are consistent over different data sets. In these data sets, for instance, the first one, the Zachary's Karate Club, is a small network, very well known in social science. And the last one, URB email, is a network with more or less 10,000 nodes, which is a bigger network with a very different structure, and the values are still more or less the same. So, as a conclusion, well, we have observed that some measures behave in similar way independently of the data in which they are applied. And what is the most important thing in this work, we found a strong correlation between some generic information loss measures, such as closeness centrality, clustering coefficient, edge intersection between the centrality, transitivity, or average distance, and the clustering specific information loss measures. Additionally, we have found that considering more than one metric can help us to get slightly values, but adding some computational cost. And that's all. Thanks for your attention.